In this video, we are given a histogram and we are asked to list 3 specific and distinct pieces of information about the distribution. If we look here on our x-axis, we see that the variable is distance. This corresponds to the question in the student survey data early fall 2009. What is the distance from your home to Cincinnati State? If we look on the y-axis, of course, this is the frequency or the number of students. So the first piece of information that we want to talk about this histogram is its shape. Clearly we can see that this is not symmetric. It is what we call skewed. Now it's either skewed to the left or skewed to the right. And the easiest way to determine that is to look for the bin that has the largest frequency, this one. So once we have determined the bin with the largest frequency, what we want to do is we want to draw the tail. Now the tail, this is called the left tail, and it goes from the largest frequency bin to the first bin. So this is the left tail. And then we want to draw what's called the right tail, which extends to the last bend to the right. So the longest tail is what we call skew. So we can see this one is clearly skewed right. Now the next piece of information we want to talk about this distribution is to see if there's any what we call possible outliers. Outliers are values that are very far away from the rest of the data. They can be to the left, they can be to the right. So as we look at this histogram, we see that there is a lot of data here, a lot of frequencies, and then we have this value way over here. So we see that this value looks like there's a frequency of 1. It's very far away from the rest of the data, so we say this is a possible outlier to the right. Now sometimes a data set may have no outliers. Sometimes a data set may have outliers to the left and to the right. But for this distribution, we would say this is a possible outlier to the right. Now how do we determine if it's an actual outlier? We'll discuss that when we get to box plots. Now the next piece of information we want to talk about this distribution is about its peak. We can see that this bin, or it could be called a class, has the largest frequency. Well, before we can talk about this bin, this class, we need to figure out what is the class width. We can see that the labels are midpoints, so we can determine the class width by doing this. This is 0, this is 8. So the question is how many bins are between 0 and 8? Well, we can see this is a whole bin, so we have 1. This is a whole bin, 2, and then we have 3. Then we have half a bin here, and we have half a bin here. So that's a total of 4 bins between 8 and 0. So to determine the class width, we would take that value of 8, subtract 0, that gives us this distance, which of course is 8, and then we divide it by the number of bins, which is 4. So 8 divided by 4 is 2. So the width of each bin is 2. So this starts at 0. This would be 2. Then we add another 2, and that would be 4. And then we add another 2, and we'd get 6. And so on and so forth. So now we know that the class width is 2. Now we can go to the bin that has the largest frequency and talk about that peak. we know this bin has a midpoint of 6. So I'm going to mark 6 here. Now, it would be incorrect to say that there is about 90 students who have a distance away from home to Cincinnati State of 6 miles. The reason why is this bin is a class. It has an upper limit and a lower limit, and 6 is just the midpoint. So we need to determine what is the lower limit and what is the upper limit. So imagine if we look at this bin, we have a midpoint of 6. What we do is we needed to determine what is this lower bound and what is this upper bound. Now, since we know that the class width is 2, then we know that this is half of 2, and then this is half of 2. So this lower limit would be half of 2, which is 1. So 6 minus 1 is 5. And this half is also 1. And we want to add it to 6 because it's getting larger. So 6 plus 1 is 7. So the correct way of talking about this peak is not to use the number 6, but to use the class numbers from 5 to 7. So what we can say is we can say that the peak is here, which means approximately 90 students have a distance away from home to Cincinnati State between 5 to 7 miles. It would be incorrect to use a 6.